everybody, welcome back to videos about logs. Let's start off with practicing the evaluating skill that we actually learned in class. So remember that log stands for what exponent. This really says what exponent do you put on 2 to get 8? What exponent do you put on 2 to get 8? Well, that's 3 because 2 cubed is 8. Let's try the next one. What exponent do you put on 2 to get 4? Well, that's 2. So this problem is saying, what is 3 plus 2? Well, that's easy. The answer is 5. I want to show you a property that we can actually do in case we actually can't find the exponents, and that happens sometimes. So notice we were able to evaluate each individually. Let's say that we didn't do that. So I have a new property for you. Our first property is if we have two logs and we're adding them together, and as long as they have the same base, so I'm going to put a B for the base, and let's say that up here we had something like, I don't know, X, and we're going to add, like I said, to another log with the same base. Let's say that this is log base B of Y. I'm here to tell you that you can actually add these logs together if you combine them into a single log. So I'm only going to write log once. Keep that base, and then see these two things out here? We're going to multiply them. So x times y. So that is our first log property. Let's use the example above to see that that works. So the example we did above was log base 2, 8 plus log base 2, 4. Okay, so according to this, they have the same base, so we're allowed to add them into a single log. So I'm going to keep the log base 2, and we would multiply the 8 and the 4. Well, 8 times 4 is 32. Perfect. Now let's see. Remember that log stands for what exponent? What exponent do you put on 2 to get 32? 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32. So the answer is 1, 2, 3, 4, 5. And that's exactly what we got above. So there's our first log property. Let's do another. Our next property is pretty similar. Let's say we have log base b of x, and this time we're going to subtract log base b of y. Can you guess how we're going to combine them into a single log this time? Well, on the previous example, when we added logs, we multiplied the x and y. When we subtract, we're going to divide them. Just like that. So let's try an example. How about log base 2, 32 minus log base 2, 4. So according to this property, we're subtracting logs. We're going to get a single log as long as they have the same base, which they do. And we would divide 32 and 4. 32 divided by 4 is 8. Alright, could we evaluate this? What exponent do you put on 2 to get 8? Well, that answer would be 3. Excellent. So we have our second log property. Okay, I'm going to teach you one more. For our last property, it's kind of a strange one. Let's say that we have a log. I'll do log base b of x. And we are going to multiply that log by some number. Let's say that that number is m. Something that you can do with this, especially when you're solving equations, is to actually change the m into the exponent on x. So basically, I took this m, moved it up here to be an exponent. That's a very odd rule. but it has a lot to do with exponent rules. I don't know if you've noticed, but we've actually been doing the inverse of exponent rules. So there's our third property. Let me just give you an example of that. Let's say we have 5 times the log base 3 of x. Now for some reason, you might not want to have this 5 out front. And you really probably won't understand what I'm talking about until we do more examples later on in the chapter, but I still want you to know this property. And it's perfectly fine for you to change this into log base 3 of x to the 5th. I want to make a little note though. As soon as you do that, you actually have changed something about the problem. And that's actually the domain. And that's all I'm going to say for now. Something did change. I wouldn't say that these are necessarily always equal. All right? But sometimes you have to move this exponent, move this number in front. This is called a coefficient. Sometimes you have to move it up to be an exponent in order to solve a problem. That's where those extraneous solutions come from. A little foreshadowing. All right, good luck with your practice.